next concept is testing of DC machines. A company manufacturer designing the machines and is releasing the machines to the market after testing of machines. Why we are going for the testing? So what is the necessity? So we know that the performance of a student can be known by seeing his marks and pass percentage. And similarly, same way, the machine performance we can know that by you calculating the efficiency of machine and regulation. What is efficiency? The efficiency is output power divided by input power. So efficiency is equal to output power divided by input power into 100. So that is called the efficiency. If you go for the efficiency of percentage efficiency of motor, the output power can be expressed as input power minus losses divided by input power into 100. So if you go for the efficiency of generator, output power divided by output power plus losses. So if you want to calculate the efficiency of motor and efficiency of generator, so the losses will be common here. If you observe, for motor input power is known, that's why the output power can be right in terms of input power minus losses. The efficiency of generator can be written as output power by input power is replaced with output power plus losses. In order to know the losses, we are going for the testing of machines, and we will test the machine if we know the losses, and we can find the efficiency also. There are two methods. One is called the direct method. So this one is direct method, and one more is called the indirect method. So direct method of testing and indirect method of testing. So in a direct method of testing, we are directly load is applied. Yes, mechanical load is applied to the motor. So to the motor, how means we are having a brake drum. The brake drum is connected to the shaft of a DC motor, and we are tightening the belt with the help of a springs. Directly we are applying. Then we will see the what is the voltage rating and voltage value and current value by applying a mechanical load on the DC motor. This method is called the direct method. It's a direct method. What is the disadvantage of the direct method means? The temperature rise. So if you go for the disadvantage of direct method, disadvantage of direct method, first of all, the temperature rise is not included. The temperature rise is not included, and some of the power is wasted in the form of heat. In the form of heat. So that is the disadvantage of direct method. So what is the indirect method means? We are not applying physically load to the DC machine. So that's why it is called as a indirect method. In that indirect method, there are two tests are there. Swimmer's test, Swimmer's test, and Hopkinson's test is also there. A Swimmer's test and Hopkinson's test is used for the shunt motor. And why? Because this is not suitable for the series motor we are not using this method. So we'll go by one. So these are the test: brake test, Swimmer's test, advantages of Swimmer's test, disadvantage of Swimmer's test, regenerative test. The Hopkins test is also called as a regenerative test. And merits of that means advantages of Hopkinson's test, retardation test, and running down test, field test, and for series motors. These are the servers. The first method is direct method. In this direct method, I have a brake test on. So this test is called the brake test on DC shunt motor. If you observe this diagram, so we already discussed about the 3-point starter. In order to start the motor, we can use the 3-point starter. In order to limit the starting current, we can use the 3-point starter. So here is the DPST switch is provided. Double pole single through switch. Double pole single through switch. And this field rheostat is kept at minimum position. Initially at minimum position. So these are called the brake drum. The brake drum is connected to shaft of DC motor. So this is a belt is connected to the brake drum with the help of a spring balances. So these are turned as this is called the spring balance. Okay, spring one. And now, so initially this why this is kept at minimum position means field rheostat is kept at minimum position means if a field rheostat is at minimum position, field rheostat kept at minimum position means RF is minimum, then current flows through field winding, that is shunt current, is maximum. The flux which is produced by the field winding is also maximum, and N is inversely proportional to flux. We know the relationship between the back EMF and speed and flux. EB is directly proportional to N phi, where N is directly proportional to EB divided by phi. And if the flux is maximum and speed is minimum. Start the motor with the help of a 3-point starter. After that, by varying this field, as the field resistance is increases, IF decreases, flux decreases, and the speed will be increases. Adjust the speed of the motor to the rated speed. So that is 1500 rpm for a 4-pole machine. 1500 rpm, and the frequency of the armature is 50 Hz. So frequency of the armature, once again listen students, frequency is present in an armature conductors EMF. Okay, but externally we are applying DC, the frequency is 0 for supply, and then you can apply the belt mechanical load with the help of tightening the belt using spring balances, and note down the voltmeter reading and ammeter reading. So after that, voltmeter reading and ammeter reading and speed. So then serial number, voltage, current. So this is the line current. Then I got the input power is V into IL. So spring balances S1 and S2. Then torque is equal to 9.81 into S1 minus S2 into R. R is the radius of the brake drum. R is the radius of brake drum. Then output power is equal to 2 pi nt by 60. So before that you should note down the speed with the help of a tachometer. With the help of a tachometer, you note down. After that, output power divided by input power, directly you are getting percentage efficiency. For different values of load currents, suppose if the motor rating will be 20 amperes, the full load current is 20 amperes, then directly note down the voltage value that is indicated by this voltmeter, and the current value is indicated by the ammeter, and the line current, that is current, is called the line current. In the input power is voltage into line current. Speed is also note down by using a tachometer. So after that you can directly find out the efficiency at any fraction of full load, so that is advantages of brake test. Actual efficiency of the motor under working condition can be found out. This method is simple and easy to perform and can be performed on any type of DC motor. Means you can apply this method to the DC series motor as well as the DC shunt motor. The above motor is DC shunt motor. For a DC motor also, series motor also, you can apply the disadvantages what we have discussed for a direct method. Same, if you are applying a directly mechanical load to the motor, heat will be produced, so much heat will be produced, and so that is a major disadvantage, and actual efficiency we won't get. That is a major disadvantage of brake test. Thank you. So okay, and one more, cooling arrangement is required. Cooling arrangement is required. Arrangement is required, and this is suitable for small machines only. These are all disadvantages of brake test of DC motor. And the power is also wasted in the form of heat. Power is wasted in the form of heat. Power is wasted. Power is wasted in the form of power is wasted in the form of heat. The efficiency observed is on lower side. Okay, and one problem we'll discuss. So on brake test, I will take a red pen. Okay, in a brake test, so in a brake test conducted on a DC shunt motor, the full load readings are observed as tension on tight side is equal to 9.1 kg. Tension on slack side is equal to 0.8 kg. Total current is equal to 10 amperes. supply voltage is equal to 110 volts, speed is equal to 1320 rpm, radius of the pulley is 7.5 centimeter. Calculate its full load efficiency. This is our question. The solution for this one. So torque can be calculated W1 minus W2 into or S1 minus S2 into 9.81 into R. The spring balances is one side is W1 is 9.1 kg. W1 is 9.1 kg and W2 is zero point 0.8 kg. So 9.1 minus 0.8 into 9.81 into the radius of the brake drum is 7.5 centimeter. 7.5 into 10 to the power minus 2. That should be equal to 6.1067 Newton meter. If I am getting the torque, power output power 2 pi nt by 60. 2 pi into the speed which is given. The problem is 1320. The shaft power is 6.1067 divided by 60. The shaft power is equal to 844.133 watts. Then power input is equal to V into I, voltage into current. The total current is given as 10. Supply voltage is 110. So now this is 1100 watts. If you calculate the efficiency, power output by power input into 100. So substitute in the equation, power output is 844.133. So this is 1100 into 100. That should be equal to 76.74 percentage. So this is one of the important problem on brake test on DC shunt motor. So you observe an overall discussion. Directly you can calculate the efficiency of a DC motor. Thank you. So one more problem on a brake test on DC shunt motor. The following readings are obtained. The following readings are obtained when doing a load test on DC shunt motor. DC shunt motor using a brake drum. So spring balance reading is equal to 10 kg and 35 kg is diameter of drum is equal to 40 centimeters. Speed of the motor is equal to 950 rpm. Applied voltage is 200 volts. Line current is equal to 30 amperes. Same, calculate output power and efficiency. What is the solution for this one? W1 is 10 kg, W2 is 35 kg. Means in the previous one S1 and S2 and W1 and W2 both are same. S1 and S1 is equal to W1, S2 is equal to W2. The notation will be different, that's it. Diameter is given. So the most of the students they commit a mistake Instead of substituting the radius, they directly substitute diameter. But you should calculate the radius diameter by 240 into 10 to the power of minus 2 by 2. So 20 into 10 to the power of minus 2 meters. Then the line current is 30 amperes. Our supply voltage is 200 volts. And the speed is 950 rpm. 950 rpm. So find out the shaft torque. 9.81 into W1 minus W2 into R. 9.81 into what is the W1 value is 35 kg, W2 value is 10 kg, and the radius is 20 into 10 to the power of minus 2. Then finally I got it as 49.05 Newton meter. Now the power output is equal to 2 pi shaft torque divided by 60, 2 pi into 950 into 49.05 divided by 60. So that should be equal to 4.87 kilowatts. Then the power input is Vi 200 into 30, 6000 watts, 6 kilowatts. Finally, efficiency of the motor, power output by power input into 100. Oh, thank you.